Okay, so U substitution was helpful when a composition was involved, or when chain rule had been applied in the derivative to get that integrand. Integration by parts is useful when it has been product rule, or you have a product in your integrand, okay? So you don't have to write anything on this page except the cloud and the last line. Don't write them yet, put your pencils down. Let's just talk about where integration by parts is coming from first. This is in your book, but it's always a good idea to know where something is coming from. So, I'm telling you we use integration by parts when there is a product rule applied. So let's look at the product rule for differentiation, for derivatives. If I want to take the derivative of a product, I get the first times the derivative of the second, plus the second times the derivative of the first, correct? That is product rule. So to get the integration by parts, which comes from that, we integrate that whole equation. So I'm integrating this entire equation to work backwards to get my new method for integration. Well, what happens when I do the integral of a derivative with respect to the same variable? You get the same, you get the argument. They undo each other. The antiderivative of the derivative, they do it just the argument. So that's where the PB is coming from. And over here I'm taking the integral of p times dB dx with respect to the x. We get a cancel here and we're left with the integral of p dB. Make sense? Okay. Same thing happens on the second term. The integral of d dp dx with respect to dx, we get a cancel here and we're doing the integral of d dp. Okay? Alright. When we set up for integration by parts, we're solving an integral that is a product. So that's why I've isolated this integral and rearranged. The integral of p dB is equal to p times d minus the integral of d dp. Okay, that means nothing to you yet, but that is the format for integration by parts. And I wrote it in p's and b's because my u's and b's look very similar. But most often you see integration by parts written with u's and b's. So these are the two rows I want you to have as in. The integral of u dv is equal to uv minus the integral of v dv. And now we have to see how that's helpful. What time am I out of this class? Okay, moving on. Here we go. So we'll get a couple of examples in of the types of problems we'll be looking at. Oh! Oh my gosh. There's going to be a mad dash. That's better. Okay. So let's look at this one. The first thing that you must do when you are applying integration by parts is to look at the integrand. So when I look at this one, do I see a product? X times cosine x. Try use substitution first, because if you get really good at that and it works, then use it. Will it work here? There's no good choice for you. Nothing's going to go away. So we're going to use integration by parts. So the first thing you have to do with integration by parts, let's write down our little integral of u dv is equal to u, my u's have tails versus my v's. uv minus the integral of c dv. So we need to find or name or choose all of those four parts. All right, when you look at this one, you want to pick a u that when you take the derivative, it's very easy. So if I have x and cosine x, which would you choose? X. So we're going to choose our u to be x. And that means our dv, because what we have on the left is u dv, must be everything that's left, cosine x dx. Okay. Well, to plug into the right side of this equation, I'm going to need v, and I'm going to need du. So how do I get du from u? Take the derivative. Du equals 1. If it is du, then it should have a dx over here. Du is equal to 1 dx. How do I get from dv back to v? Take the antiderivative. So what is the antiderivative of cosine of x?
Negative sign.
What did I start with? Get cosine as my derivative. Positive. Sine x. And what else would you like to put there? Don't do it though. Plus c. All right. I will tell you that within your process, all your little plus c's that you would put in with c here would cancel out. And then we would have to add a plus c at the very end. So my suggestion to you is to only do your plus c at the end, so you don't have a tracking nightmare of following your c. So the first thing you do is you choose your u and dv. Then you find du and, oh, that's right, and v. And my third hint is do a plus c at the very end. Okay? All right, so let's rewrite what we have. We have the integral of x cosine x dx equals uv. What is that? X sine x. Then minus the integral of v du. And what is that? Sine x dx. Can we do that integral? Do we know the integral of sine x? Life is good, so let's finish. We get equals x sine x minus, what is the integral of sine x? What did I start with to get sine x as my derivative? Negative cosine. And then, let's see, we're done. So we get x sine x plus cosine x plus b. Questions on what we have? There's our solution. And now I will show you the difficulty that comes up with not knowing the tabular form, what we will do next. Quite often, when we set up our integration by parts, we end up with another product here. And then what would we have to do? And then another integration by parts for this one. And then you get down here and there would be another product in your integral. So it is a tracking nightmare of positives and negatives, especially with trig functions. And it is very error prone. We can do it with this traditional method for integration by parts. But life is easier with the tabular form, which is we'll do the exact same problem now using the tabular form. So just further down on this page, we'll do tabular form now, and the only difference is the way that we organize our information. We're still doing the exact same process, but it's cleaner. So tabular form. The integral of x cosine x dx. All right, we make two columns. We make a u column and a dv column. I want you to be aware that the u column, as you go down, you're taking derivatives. And the dv column, as you go down, you're taking antiderivatives. You still choose your u and dv using the same thought process. So what will we choose for u? X, which means dv is going to be cosine x. It is cosine x dx, but I don't put the dx's in my column because it just gets a little bit. I just leave those off. All right, so now, when you are doing the tabular form, one type of problem is the one we're doing now, where you can find a u that if you take the derivative a couple times, you get down to 0. And that's very handy. So it's one thing to look for when you try integration by parts. So when I take the derivative of x, what do I get? 1, and if I do it again, what do I get? 0. So it quickly goes to 0. That is something handy to look for. It doesn't work all the time, not in every type of problem, but it's something handy to look for. All right, then we need to have the same number of rows for dv. What is the antiderivative of cosine x? Sine x. And antiderivative of sine x? Negative cosine x. The way this works is, remember, on the right side of our integration by parts, the first thing we have is uv. Well, this is u, and this is v, the second item in the right. So we use a diagonal arrow. On all of the arrows, we are multiplying what's at the end of the arrows. We do a diagonal arrow here, and your last step is not always 3 steps, but in this case it is. We do a horizontal arrow back, which is still dealing with a product here, but on the horizontal arrow, that's when you always integrate back. Because remember, in integration by parts, there's always that minus the integral of b du. So that horizontal line is integrating back. Okay, to keep the signs correct, it's very easy. In the tabular form, it's always alternating, starting with plus. Plus, minus, plus. Okay? Our solution is read along the arrows, and again, each arrow is a product. So our first part of our solution is x sine x. They're both positive, and we have a plus on the arrow. So x sine x. Will the next one be positive or negative? Negative there, the product. So what is it? Plus 1 times cosine x is just cosine x. Okay, the next one, will it be positive or negative? It will be 0, but will we subtract it or add it, just so we have that? We'll subtract it. So minus, and it's the integral, because you're always integrating back on the horizontal, minus the integral of 0 times cosine, which is 0, dx. Okay, well, what is the integral of 0? It is a constant. So really, looking at this, we would say x sine x plus cosine x, then what would you tell me? Minus b? All right, well, I don't like minus b. So I would immediately say, okay, well, I'm going to let c1 equal negative c. So then I can write x sine x plus cosine x plus c, the way I like to do a plus c. Do you have to do that step every time? Nope. You can just do a plus c. And I've just shown you why you can do a plus c. Okay? Falcon? And you can leave it as minus c. Yeah, you can. Okay. So, comparing the traditional version to the tabular version in this problem, there's not too much difference in the amount of work. But there are in others. So, let's try another one. So this one is a different type of integration by parts problem, and as you look at it, you'll see why. In the first one, we wanted to pick our u, so that as we take derivatives, it gets simpler. But in this problem, take a look at our integrand. E to the x times cosine x. Do either of those go to 0 in our derivative? No, they don't. So it's a different type of integration by parts problem. So, in this case, you could choose your u to be cosine x, or you could choose it to be e to the x. I tend to always choose my u to be the exponential. Just have it. So we're going to do it that way, and you can investigate and see that it works out fine the other way as well. I have u and dv. I'm only doing this one in the tabular method. Okay, so when it doesn't simply go to 0 in the derivative, another thing you can look for is for a repeat of the integral of u dx cosine x to show up in our table. So you have to think about in each row, if I integrate back, if I draw a horizontal line, would I get e to the x cosine x again in my integral? Okay, so I want you to stop me when we get to that point. All right, so I said I choose e to the x, see my u, that means my dv is cosine x. Okay, what is my next derivative? Our favorite, e to the x. What is our antiderivative? Sine x. So if I were to draw my horizontal arrow here, would I get a repeat of the original? Nope, not yet. So let's do the next one. Next derivative is e to the x again. Antiderivative? Negative cosine x. Without worrying about the sign, how's this row look? I'd have it, right? The sign doesn't matter. I would have a repeat of my integral, the integral e to the x cosine x. So we're going to stop there and draw in all our arrows. Be neat and tidy in your tabular form, please. There, there, and integrate back here. We have plus, minus, plus. Now, with the type where you're looking for a repeat, it's really useful to remember to rewrite the original so you can see what's going on. So we're going to have the integral of e to the x, that's an x, cosine x, dx, equals, now help me with my solution. E to the x sine x plus e to the x cosine x, then minus the integral of e to the x cosine x dx. All right. Remember what we're trying to solve for. We're trying to find out what the integral of e to the x cosine x dx is equal to. What can we do? We can add. We can add that integral over to the other side, so we have two of them. Plus the integral of e to the x cosine x dx. And over here. So now I have two of those. Equal to that right side, e to the x sine x plus e to the x cosine x. And finally, what can I do? Divide by 2. And we remember in the end, plus b. And there's our solution. All right, your homework is on your assignment sheet. It's on the front side. And I want a true attempt on every problem. If you're stuck, look at some of the examples we couldn't get to in class. Okay, now that you know what you're doing, it'll be easier to look at those yourself. I will check this homework and the one due today first thing tomorrow while you start your Colorado Math Week. And then you get extra practice on use of and integration by parts. And I think we have a quiz, don't we? Quiz on Wednesday. Thursday. Okay? All right. I will be here early tomorrow. After school Tuesday, Wednesday, Thursday. Tutor time Wednesday. And any fourth period, you can come into my office.